My name is Moira Zellner. I'm a faculty in the University of Illinois at Chicago. What we've been doing for the last 10 years in participatory modeling and developing tools for stakeholders to engage in modeling of complex social and environmental problems and be able to come up with solutions for them. We started with this project about 10 years ago, and what motivated it was that what we were seeing is that there were all these complex environmental and social problems that were very difficult to tackle, and that modeling of those problems was important to advance decision making. The problem is that when we do modeling, they tend to be very complicated. So the people who are making the decisions and are not trained in doing that modeling cannot really engage with understanding how these systems work and why or how, in what ways these problems are difficult and what can be done to address them. This map represents the same neighborhood that you have there on your iPad. So when you look at the guidebook, it's going to be the same map, and it's the same map that you see there that is in the simulation. So you're going to recognize the surrounding streets, the lawn, the buildings, and the paved surfaces. And here what we have is different kinds of tiles that represent different kinds of green infrastructure and where they can be placed. So you've got rain barrels and roof gardens that can be placed around buildings. Bioswales that can be placed anywhere where it's green, so wherever there is grass. Bioswales can also be placed in areas that are hashed, so that where there's some kind of pavement, as well as permeable pavers. And each one of them, remember, has a different cost associated to it for implementation and for installation and maintenance. So Dean just took a picture of the scenario that you all created, and that is converted into an input to the simulation. And now we're going to run that simulation that you can start to try to see then how this scenario works for this particular storm, in this case a 5-year, 24-hour storm. And in the beginning there isn't much happening. You can't see much happening because the sewers were working and the infrastructure was working too. But now you can see that there's a little bit of accumulation in some of the lower areas. So this is what is called the concern profile. Each participant has one of these so that they can represent their priorities and what they really care about the most. So for example, if I'm a public official, I probably want to rank investment high because I want to minimize the amount of funding that I have to use to try to address a flooding problem by using green infrastructure. If, on the other hand, for example, I were a hydrologist, I would have a very different set of priorities. Most likely, I would prioritize groundwater infiltration because that is what helps get rid of the flooding. Maybe also rank an efficient flow path and minimize the depth of flooding. So as you see, the way that I will rank and then evaluate different kinds of scenarios, the weight that I give to the impact of each one of these scenarios on these different kinds of variables or categories is going to be different depending on what my priorities and my preferences are. In these kinds of situations, what happens is that we lose opportunities to learn together and to innovate because we really don't understand the complexity of the problem, and we also don't understand the complexity of our social and diverse preferences and values. So what we wanted to do was, around the idea of complex system simulation, really provide tools and platforms for people who are making decisions about these complex issues to engage in the modeling and be part of the analysis together with those who are building these tools, and then together be able to come up with novel solutions to address them. What we see is evidence of people learning, not just about the problem and the biophysical aspects of it, but also how to use what they learned to come up with solutions, and also understanding what the trade-offs are when we come up with different kinds of solutions. Some people gain, other people lose. What do we do about that? And so this is a system, a platform that allows for that kind of deliberation and where people can converge towards solutions and compromises that they can all live with. In the future, we can build on this to make it, to scale it up essentially, and allow for more people to access and use these kinds of tools, but also apply it to different kinds of issues like, for example, heat island effects, or other kinds of social or environmental issues that are in general difficult to tackle and that require a lot of different kinds of actors, agencies, scales of decision making to be integrated in order to really advance on that.